Right, here we go. Another example coming from the people that wrote your textbooks. So they know their stuff. Here we go. In a long-term study of 3,462 randomly selected adults from Switzerland, researchers investigated the relationship between weekly napping frequency and whether or not a person experienced an event related to cardiovascular disease, so CVD, such as heart attack. So the two-way table summarizes the data below. Ta-da! All right. In the sample, 4.5% of people experienced a CVD event. So yes, so that's 155 out of 3,462. To what population can this result be generalized? Explain your answer. Got it. Well, since they did do random, right, randomly selected adults, due to the random sampling, researchers can generalize this result to the population from which the sample was selected. And it would be all adults, all right, all adults from Switzerland. Lausanne, probably. Lausanne, Switzerland. All right, so B, one person from this survey is going to be selected at random. What is the probability the person selected will be someone who reported taking a nap at least 3, right? At least 3 naps per week. So up here, at least 3, so that means 3, 4, 5, 6, or 7. So we could be here or here. So we've got 411 and then another 370 that had at least 3 naps in a week. So adding those two values together, 311 and 370, you get 781 out of the grand total 3462. Notice it says you can leave your answer as an unreduced fraction because the AP exam has stated that you do not have to have a calculator to do these calculations. So we're expecting that they don't care if you leave it unsimplified. All right, so fancy pants notation, show your work, always show your work, and then there's your answer. Next, what is the probability that the person selected will be someone who has experienced a CVD event given, I'm thinking slash bar, given the person has taken at least 3 naps per week. All right, so probability of CVD given 3 naps. Okay, so this given denominator is going to represent just those 3 naps. So at least 3 naps, we just calculated as 781 people, right? 411 plus 370, that combines up to 281. All right, so out of those 781 people, what is the probability of having a CVD event? So now I got to go back to that table. We're looking at a yes, right? They had a CVD event. So 22 here and 28 here. So 22 and 28, if we combine those up, we've got 50. So 50 out of those 781 nappers had a CVD event. Flippity-doo-dah. All right, so P of F is going to represent the proportion of people who have experienced a CVD event among those in the population. And that's with the frequent napping. P I, that's an I, is going to be infrequent napping. So we have frequent and infrequent. The 95% confidence interval has already been calculated, 0.0062 to 0.0435. Again, the AP exam does not expect you to have TI Joe. So chances are they're going to go ahead and do the work and have you do the interpretation like you're about to see here. One condition for constructing this confidence interval is that the number of people who experienced a CVD event and the number of people who did not is at least 10. That's your ring ring, Jake from Stat Farm discount double check. Right? We want to make sure our distribution is normal and that we don't have any major outliers. Explain why it's necessary for this condition. Okay. Z star, that's your critical value, is based on how many standard deviations away from the mean you are willing to go, right? How many hops are you willing to go to cast your net? So this critical value is based on bell curves. So the condition, right, this normal condition is necessary because the formula for confidence interval relies on the fact that the sampling distribution, frequent minus infrequent, right, which is what they have here, is approximately normal. This will be the case if n times p is at least 10, right, successes, And then failures is at least 10 for both. And then I added a little extra. The critical value is based on a normal curve, Z star. All right, interpret your confidence interval. Okay, so that's your go-to sentence. We are crazy. We are orange. We are 95% confident the interval 0.0062 to 0.0435, which is what they gave us, captures the true difference between the proportion of CVD event among all people who nap frequently minus naps infrequently. Writing this sentence, all I did was steal their language. Right? I just stole their language. All right, so this is just your basic interpretation. I'm going to go a little bit farther, though, because this is a difference between two. And notice 0 is not captured and negative numbers are not captured. So if your interval is entirely positive, that means frequently, right? Napping frequently is going to have a larger proportion, right? It's entirely positive interval. Because the interval is positive, it appears there is a slight difference between the groups. There is a slightly larger proportion of CVD events for people who nap frequently. How much more? Well, it was 0.0062 to 0.0435 more. So not even 4% on the high end. All right, on to the last one. Even though all the values in the confidence interval are positive, a cause and effect relationship between napping and CVD cannot be established from this study due to possible confounding. Identify a potential confounding variable in this context. Also, side note, cause and effect can only be used if it's an experiment. And this right here is not an experiment. We did not experiment on people and say, you must nap. Let me check your heart. Instead, it was an observational study. Okay, so I went with age. Age is a potential confounding variable. Older people might tend to nap more frequently. And because they're older, they might also tend to experience these CVD events. So perhaps it's age and not the napping that's related to CVD. Could you think of any other ones? Maybe. The age to me is the easiest one to get through. All right, on to the next problem.